My name is Abby. I'm with the Material Science and Engineering Department. Question 1, anybody know what a material science engineer does? What is it?
Work with materials.
Work with materials, right. So when material scientists say materials, we mean things like plastics, rubbers, polymers, metals, semiconductors, ceramics, the whole thing. And what we do is we take a material and we change its environment and then look at how the properties of the material change after we change their environment. So here I've got a racquetball. When I drop it, what will happen? It'll bounce, right? So drop the racquetball, it bounces. Here I've got liquid nitrogen. And what I'm going to do is I'm going to douse the racquetball in liquid nitrogen and then drop it and see what happens. So does anybody know how cold liquid nitrogen is?
How cold is it?
Really cold. That is a great guess. Anyone want to tack on a number?
I think it's like minus 200 Celsius.
Minus 200, minus 400. Actually in the middle. Liquid nitrogen is negative 321 degrees Fahrenheit. So very, very, very cold. What I've got here is a racquetball, and I'm going to douse it in liquid nitrogen and then drop it. What will you guys think will happen when I drop it? It'll shatter. Why do you say that?
Seafood
Just guess 'cause
Network.
it's frozen. Anybody think it'll bounce? No? All right, well, let's see. All right. Let's see. You guys ready? All right. What happened? It broke. What did it sound like? Hard. It sounded hard. It sounded kind of like a metal. Did it sound like a racquetball when you bounce it? So, I've got a tennis ball here. A tennis ball is made of the same kind of rubber as the racquetball. So when I douse it in liquid nitrogen and drop it, what will happen? You said it'll shatter? All right, let's find out. Ready? What happened?
Still containing the liquid nitrogen within it.
Not quite. Did it break? All right, so if the tennis ball is made of the same material, then that can't be the answer. So let's look and find what the difference is between the racquetball and the tennis ball. So can you guys see? What's the difference? Plop, fuzzy? Exactly. So the tennis ball has all of those little fuzz fibers on the surface, but the racquetball is smooth. So when I take the tennis ball, dunk it in liquid nitrogen, and take it out, all of those fibers have more opportunities for the tennis ball to warm up from the atmosphere. So we can say that the tennis ball has a higher surface area, whereas the racquetball has less on the surface, which means less opportunities for it to warm up from the atmosphere, so that by the time I drop it, it's still really, really, really cold and will shatter. So okay, you guys think, great, you guys can freeze tennis balls and drop them. What's the point? We're engineers, we like applications. Think about the Titanic. What happened in the Titanic? It sunk. What did it hit? An iceberg. So if we think about what happened with the racquetball and extrapolate that to the Titanic, what can we infer about the temperature of the water from the Titanic? Cold, right? Very, very cold. So when we took the ship of the Titanic and put it in those cold ocean waters, what happened there was the same thing that happened to the racquetball. The cold waters cooled it down past a certain temperature, and instead of being ductile, which means that we hit it and it bends, the metal turned to brittle. We hit it and it breaks, like the racquetball or like a ceramic or like a glass. So when it hit the iceberg, because it doesn't make sense, right, for a big feat of engineering ship to nick an iceberg and for the whole thing to just catastrophically fail. But because the ocean water was so cold, when it hit the iceberg, it cracked, and that caused the Titanic to sink.
So you're saying if it was fuzzy, it
If it was, if the Titanic was fuzzy, it wouldn't have sunk. That is my favorite thing that has been said all day. Oh, that's so good. Okay, so in material science, we can also think about gases, although not as often as metals, not as often as solids. So I've got a balloon here. What is the balloon filled with? Oxygen, air, right? When I put it in the liquid nitrogen, what will happen? Besides flying away. What will happen? Anybody have a guess? Get smaller? All right, let's see. Oh, no. Yeah, there we go. What's happening? Is it getting bigger or smaller? Smaller. All right, so I'm going to show you guys the bottom of this balloon. There we go. Let's see. Oh, maybe. Sometimes that works, sometimes it doesn't. All right, I'm kind of short, so bear with me. What do you see at the bottom of the balloon? Liquid. What happened? So when I blow air into the balloon, what's in the air?
Moisture.
Moisture. What do you mean? What's the chemical? When I say moisture?
Hydrogen. Like basically a hydrogen base.
Hydrogen, right? So, and then what else is in the air? We've got oxygen, carbon dioxide, what else?
Nitrogen.
Water vapor. Who said water vapor? You were right, whoever that was. So what happened is the water vapor in my breath when I blew up the balloon cooled down so much from the liquid nitrogen that it underwent a phase change. Did you learn about phases of matter in school? Phase change, no, it's fine. From a gas to a liquid. So let's think about why we see this steam from the liquid nitrogen. Nitrogen makes up 80% of our atmosphere, so it doesn't make sense that this steam is nitrogen, because if it was, we'd be walking around in a cloud of white stuff all the time, right? So that's not it. Think about what happened with the balloon and tell me why you see this steam here, or why you see this white gas. What is it? What's happening? Exactly. The water vapor in the air surrounding the liquid nitrogen is condensing from the liquid nitrogen and turning from a gas to steam, to this water vapor. So there you go. Like I said, I'm from the Material Science and Engineering Department, so if you guys have any questions, I'm happy to answer them. There's also some people over here who are happy to answer any questions you have. We've got liquid nitrogen ice cream over here. If you guys haven't had that before, it's super good. And then on the third floor, we've got an electron microscope. If you haven't seen an electron microscope before, definitely check it out. It is probably one of the coolest things on this campus. And then, like I said, I'm happy to answer any questions, and if not, continue exploring and have a great day. Thank you. Yeah, you're welcome. Thanks, guys.